Thank you for watching this video. Please click on the like and subscribe buttons so that I can continue to make more videos like this.
The next page of this lesson is sheet E 4.2, Mechanical Power Plan. Now the scale on this sheet is 1/8 of an inch equals 1 foot. And of course we should read the keyed notes and the notes every time. Let's look right here. We have keyed note 5 and it says existing 1200 amp 280 120 volt 3-phase 4-wire SES. In other words, this is where the electrical feed from the utility company comes in. And remember, our panels were over here, and there will be a disconnect to shut down panel E4 and E5 over here. So this is where the main panel for the whole building is, and this is the first look we get at that with these prints. This page on the prints is a rooftop look of the prints, and it's the mechanical power plan. The heat pumps, the air conditioning units are on the roof, and we can read our keyed notes. It goes into detail on these. Now I don't want to read them, it's a lot of numbers, but to get into it, it tells you the conduit. It uses number 8 wires and a 10 ground from panel as noted. It tells you the type of fuses and to use a fuse disconnect for these. So we're going to zoom into this part of the print now. This is our section, our build out part of the building, and we have 4 heat pumps if you remember. Here they are. And you remember the types, they had A, B, and a C type, and here's an A and a B, another A, and here's the C. We have here panel E4, circuits 2, 4, 6, E4, 8, 10, 12, and these next two are on panel E5, 1, 3, 5, and E5, 7, 9, 11. So they've split the heat pumps up onto 2 different panels, so you just have to be aware of that and just don't make an assumption that they all go to the same panel. Okay, another thing we look to at the heat pumps, you can see, of course, we got the line with the arrow which shows home run. We've covered that symbol before. But there's a little box on the side of each of these where the arrow comes out of. That's where your disconnect goes. On your heat pump, it may not actually be on that side of the heat pump. It just depends on the model. And this is just, again, a symbol that the architect puts on there. So you actually have to look at the heat pump, how it orients on the roof, and put it on appropriately. You can find that information. Remember sheet M 2.1. We've already looked at the packaged heat pump unit schedule. You can get the model number and all of that, and you can actually find the orientation on the unit and find out where that disconnect should go on that unit. And that way you can properly plan your stub outs. Now the nice thing about these units here is that there's a little cabinet in there, and the stub out actually goes into the unit. You don't have to put a stub out beside the roof and make another roof penetration. So that's what made these units pretty nice. Another thing we see here, we got this line E4 circuit 14, and we have a note 4, and it says 3/4 inch conduit, 2 number 12 wires, number 12 ground, be used for each 20 amp circuit. These are the convenience receptacles for your roof. Within a certain distance of each of these heat pumps or any piece of equipment on a roof, you have to have a receptacle so that if you have to do maintenance work on that piece of equipment, you have electricity there. So here you have one over here, and this one will be shared by these 3 because it's close enough. Now let's take a look here. It says WP. From our abbreviations, we know that that means weatherproof. And GFCI is a ground fault current interrupter. And so it's a GFCI plug, and it's a weatherproof outlet. So that's what that takes to make that work. Let's refer to note 6 right now. It says, all exterior receptacles shall be furnished with a Tay-Mac cover. So we have these 2 receptacles here. You might be tempted, if you don't read this note, to just put the standard Bell is a common name for a company that makes weatherproof boxes, and you might just be tempted to put a regular Bell cover over it. A Tay-Mac cover is different, And this is what this is calling for. So you have to read these details and make sure you install the right features. Otherwise, you're going to have to go back and change that out. We did mention about sheet M 2.1, and we already looked at that earlier, the packaged heat pump unit schedule. But I would like you to turn to that page and review the equipment here, these 3 heat pumps. Just go over the features of those heat pumps again. Please do that before we go to the next page of our prints, which would be sheet E 5.1. The next sheet of this lesson is E 5.1, and it's one-line diagram, schedules, and calculations. Now, we've already been to this sheet before, but we're going to take a general overview of it and then go to some specifics. Now, right here in the middle, we see load calculations, fault calculations. These are kind of engineering things, and also these load calculations over here, and it gives the part of the code you can look at. Those are things that the engineers take care of. We're not really worried about with this. And here we have notes for the page. I want to point out note 4. It says, no design changes shall be made to the system without prior approval from the engineer and the authority having jurisdiction. In other words, if you're talking about major changes to this, that's what they're talking about. They're not talking about something if you put a spare conduit in or maybe one more circuit in the panel. But it's a change that affects the SES system, again, which is where the utility drop is from the power company to this building, or how the panels are fed, or if another panel is added or something like that. They're talking about a big change with that one. Let's look up in the top right hand corner. We have lighting fixture schedule. We already took a close look at that when we were doing the lighting plan from sheet E 3.1, and you remember we have these hexagons with numbers. These are hexagons with letters. So those are the fixture types, and we get a description, manufacturer catalog number, the voltage, the number of lamps required, and the type of mounting. And this is pretty straightforward. We covered that when we looked at the details of some of the light fixtures on the lighting plan. We've already looked at that, but again, just go over it again as a review and make sure you understand thoroughly how the lighting fixture schedule works. The next thing that I want to look at is the one-line diagram. And we mentioned this a couple of times. Now we look underneath it here, it says NTS, which means not to scale. We're going to take a closer look now at this and explain the one-line diagram. Now, if you recall on the sheet before this one, it was E 4.2, the mechanical power plant. We got our first look at the SES. And I want you to just take a quick look at that right now. And you recall where the SES was and the panels were. And you can see there's a distance in between those. Now, you have to get from the SES all the way to the panels, because we mentioned your utility company drops the power into the SES, and then it has to go to the individual build-out units. So now let's come back to sheet E 5.1, and we're in the upper left-hand corner looking at the one-line diagram. Okay, now we mentioned NTS. It's not to scale. You can see it here. With the one-line diagram, the reason it's not to scale, it's a very compact look at the wiring. And it's a one-line diagram because we're just showing a simple path from point A to point B to point C, and showing how the electricity gets basically from the power company to each panel. So we start up here, and this is a very, very simple one-line diagram. I want to point out some one-line diagrams have a backup, and then they have what's called a UPS system. It's like a battery backup, and then on top of that they have a generator system, which is like a diesel-powered generator backup. And you'll find things of this nature, say on a hospital where the equipment cannot go down. Or a lot of financial institutions use that when they're processing credit cards or stock trade transactions. And let's face it, money talks. So they don't want to lose that business and not be able to make those transactions and those processes. Okay, so this represents that SES unit, really almost that whole room. This is where the power comes into that room. So here we are at the SES, and we have an M with a circle around it and a line to the side, and it's got like a couple little half loops on this line, and there's another one here. This might be considered the most expensive piece of electrical equipment there is. Those are your meters. So that's how you pay for all this electrical work. Now this symbol for meter is not in your symbol diagrams on E0.1, but that's what that stands for. It's the meter. It may have been left off of the symbols because you are not installing that. The meter is something that the utility company puts in. And from our symbols that we have on sheet E0.1, it gives the one-line diagram symbols, and you can refer to those. Here we have a fuse, right here, 200 amp fuses, which protect the panel. Now these are at the SES. Now the panels will have a breaker in them. We come here, this says new for number 4 aught THHN, THHW copper wire with a number 4 ground, an existing 2.5 inch conduit. So when this building is built, initially they put this conduit in underground, a PVC conduit. Now they got it close to that unit, and what the electrical contractor had to do was actually dig it up, and of course an engineering note, they left a plan of where they left it. Dig that up and then trench over to the panels and then finish that out in the exact location where the panels were set. This is not a dotted line, even though it was underground. The one-line diagrams aren't concerned whether or not it's overhead or underground or whatever. They just wanted to show that it's the path. And they're showing it always in a straight line. They don't care if the conduit has to have turns in it. They're just showing a straight line connection. This is something to point out. The conduit was underground most of the way, but you have to pull the wire. It tells you the size of the wire to pull into each of these panels. And these panels, of course, were side by side. And we saw that on our power plan as well. That was, I believe, sheet E4.1. You can look at that in the storage room. Now down here it tells what type of panel, 225 amp, 208, it's a Y configuration as opposed to a delta configuration, 120 volt, 3-phase, 4-wire panel board, and it's E4, and this panel is E5. Now if we had any kind of disconnect in here, it would have to show that. If we had, let's say, a transformer, sometimes you do that, you have a transformer before the panel, the transformer would be on here. If you had a transformer after a panel, you would have the panel, then the transformer, and then you'd have a panel after the transformer. So this is, again, a much more simple build out, but when you get into large applications, again, I've worked on stadiums, hospitals, microchip plants, power plants, things like that. The one-line diagrams can be thicker than this set of blueprints that you've been given. And the more complicated your facility is, of course, the bigger the one-line diagrams, and every diagram is going to be. Okay, so that covers what we need to look at with the one-line diagrams on this set of prints. So now I want to drop down and look at the panel schedules. We've looked at them briefly, and now we're really going to go into them in some more detail. Okay, so we're looking at the panel schedules. We have this one right here is the one for E4, and then the one on this side is for E5. We're going to look at the features here and find all the information we can on the panel schedule, and you'll see this is very, very helpful to us in doing our electrical work. And again, oftentimes on a large project, you could have several pages of panel schedules. This one we only have 2 panels, and we only have 2 panel schedules. So let's look at the top. This is panel E4, and it's a new panel. And the location is suite E1, which is where it's built. It says the mains are 225 amps. Okay, the manufacturer is Square D. We're fed from SESE, and we looked at that. And of course, from our one-line diagram, we could see that. It's going to have a 200 amp breaker there. The voltage is 208 in the Y configuration, 120 volts, 3-phase, 4-wire. mounting. This panel is surface mounted, which means it's going to be mounted on top of the wall, or the other type would be recessed mounted, where it would be inside of the wall. Okay, now we read across here, has load, and A is the amps, reading down here. Okay, now it has A, B, and C. Now we saw that this was a three-phase, so this is A phase, B phase, and C phase. Now in your panel schedules, your odd numbers for your circuits are going to be on the left side. Your even numbers are going to be on the right side. Okay, so we've taken kind of an overview look at this information here. First we talked about the lights. If you can read here the lights, okay, in the storage, break room, and restrooms. And that's circuit 1. So this tells what it is and the location. So it's lights in these areas, and it's circuit 1. Now this is 20 amps on this circuit breaker, and it's a single pole breaker, which means that that circuit breaker only controls circuit 1. Circuit 3, okay, is the lights in the reception area. It's a 20 amp breaker, and it's a single pole breaker. Now it's on B, so we find over here where this is information we're giving the continuous and non-continuous load and things like that. And that's a little bit beyond the scope of this lesson right now. And again, we can go circuit 5. Okay, lights, open office, 20 amp breaker, it's a single pole breaker, and that's phase C. Let's go over to the other side of the panel and let's look at the even numbered circuits. Okay. So I just want to bring our diagram this way a little bit. We have here, it's HPA. Now that's heat pump A, and we know that's roof mounted. And look, it's got this whole section. We see how this is broken up over here. Well, if you look at this line, this diagonal line that comes through, and then it's got 3. That means it's a 3-pole breaker. So it's going to take all 3 of these circuits to power heat pump A. And it's going to be a 50 amp breaker. It's going to be circuits 2, 4, and 6. Now, that only makes sense because the even numbers are going to be on one side of the panel, and you can't have a breaker that controls a circuit on this side and this side at the same time. Now, notice this. Now, it's 2, 4, 6. On this side, see how it's got kind of the top half on A? Well, here it is. It's also phase A. So that's that bottom number there. So in other words, the number for the odd on phase A is over here, and the number for the even is over here. And you can see it through here and here. Now the top number, again, the odd number is going to be on the lights. And you can see all these even numbers, 24.6 on each one on the right side. And the reason, now the ones on the lighting, you can see they're different. That means there's different numbers of lights. It's drawing a different amount of power on each circuit. For the heat pump, all 3 of the phases will be drawing the same amount of power. That's why they all say 24.6. So remember, when you have this diagonal, that means it's going to take these 3 spaces up with that one single breaker. Now, what I want you to do at this point in time, on these 2 panel schedules, I want you to find all of the 2-pole breakers. Now this is a single pole breaker over here. We had 3 of them. This is a 3-pole breaker. So I want you to find the 2-pole, all the 2-pole breakers on these schedules, and I want you to find out the circuits. I want you to find out the breaker sizes. I want you to find out what they control. And also I want you to find out what phases that those circuits are on. So pause the video right now, find all of the 2-pole breakers, and then come back. How many did you come up with? Okay, there's only one 2-pole breaker in this set of plans, so let's go look at it right now. If you have a good memory, you'll recall that in the break room there was a range and we had a 2-pole breaker. And remember that special plug we looked at when we were looking through the millwork, and we had 6 plugs and only 4 shown on the millwork diagram. This is panel E5, circuit 40 and 42. Now look, we have right here, it's a 40 amp breaker, and here we know it's a 2-pole breaker, and the diagonal slashes through here, and it only takes up 2 circuits here, because above it 38 is a spare, which means a spare, it's got just a breaker in there that you're going to use sometime in the future if they need to add a circuit. The breaker size is 40 amps. The phases, we asked what phases those were, and if you read over you can see that it's 24 amps and 24, and it's on B and C. Now you would expect, once again, these to be the same number, because from each phase you want the same amount of current going in to whatever that 2-pole breaker is controlling. Hopefully you looked at it and you came to the conclusion there's only one 2-pole breaker, and hopefully you also remembered that we went over this when we were talking about the plugs in the break room and how we had to locate those within the millwork. Okay, now we're going to stay with panel E5. We've just moved over a little bit. We've got the water heater. How many circuits feed that water heater? What type of breaker? It's 3 circuits, 13, 15, 17. It's a 3-pole breaker. It's a 30 amp breaker. Underneath water heater we have spare, 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 spare. And these are breakers that are put into the panel in case you need a spare. They're going to assume, like in most places, you add things. So they give you extra breakers there so you can add those things. Now underneath spare we have space. Okay, space, 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 space. Now a space is just a space. There is no breaker there. A spare, you have to have a breaker. So if you look at it over here on this side, on the spare, see it's 20 amps on that breaker. You go to a space, it's 0. Okay, because there is no breaker there. Okay, so let's back out a little bit and take a look at both of these panel schedules at the same time. And I just want to point out a couple of things. You need your print in front of you. Right down here, there's a number in this corner and a number in this corner. And if you go over, it says total load. And on panel E5, it's 124.9 amps. We had a 200 amp breaker on this panel, yet we only have basically 125 amps. So that leaves a lot of room for expansion. And of course you look, we've got spare breakers and spaces for more. And on panel E4 we have 77.9, so basically 80 amps, and again a 200 amp breaker. And we have lots of spaces over here and a couple of spares, and mostly spaces over here. These panels are nowhere near their maximum capacity, so if the tenant decides that they need to have a few more circuits added in, they have a lot of extra capacity to do that. And of course that's what the architect and the electrical engineer will do. They will make sure that the panels are big enough to allow for reasonable expansion and reasonable add-ons that a unit of this type might use. Now you can look at a unit of this type. Somebody could put a small restaurant in there. So imagine all of the cooking equipment and electrical equipment that would take. We already saw that the range took 40 amps in that kitchen. You'd have multiple ranges and maybe 2 hot water heaters and other things. And you might even have 3 panels if that was your situation. What I want you to do right now, and this is something you'll have to do on every job that you're on, especially near the end of the job, to make sure that you've done a thorough and complete job. I want you to go through the electrical sheets, the lighting, the power, the mechanical, I want you to go through each circuit and I want you to have it accounted for. Go through E4 and E5. Make sure every circuit is accounted for. Make sure you can find them all on the print. This is going to be important, and this is how you double check and make sure you have everything done. You have to make sure that you build everything that is on the print. And when you do startup, you're going to go through and turn on each circuit, and then you're going to be testing your outlets or making sure that all your lights come on or making sure that all of your equipment operates. So you're going to be doing that on the job anyway for real. So isn't it a good idea, I think it is, that before you build it, you become very thoroughly familiar with the locations of every circuit. So that's what I want you to do. So go through the plans right now. It's going to take you a little bit of time, but make sure, and you got a lot of clues here. Okay, this tells you it's lighting in the storage and break room or in offices, okay, or the conference room. This tells you heat pump A, heat pump C, the water heater, okay? So you can go through that. You've got a lot of clues. Just make sure that you account for everything. Each panel has 42 spaces. Now some you have spare breakers and some you have as spaces. So you can subtract those from what you need to check out on your plans. At this time, before you move on to the next page, I want you to go through and make sure that you can trace out every single circuit from these panels. Give it a real good effort, and I know that you're going to be able to do that. And if you can, that shows that you're really well on your way to understanding this lesson. The next sheet of our lesson is sheet E7.1, the fire alarm plan. And we see our scale is 1/4 inch equals a foot. I'm going to refer back to sheet E0.1. It had some fire alarm general notes on there. And the first 3 symbols for the fire alarm symbols, which was also on that same sheet, it gave some mounting heights for those symbols. Look at that, and also remember note 29 on the general notes. It said all of the dimensions would be to center unless otherwise noted. Now this kind of comes into play here with the fire alarm on this sheet and on some of the other fire alarm sheets. So I want to bring that to your attention. We did have the symbols on E0.1 and some fire alarm notes. So it would be a good time to go and review those before we continue with this sheet. So just pause the video right now and take a few moments and review those notes. So here we are back on sheet E7.1, and of course we always read the notes on our pages. We always read our key notes as well. I want to point out something on our notes. Note 3, it says minimum conduit size shall be 3/4 inch EMT. You're going to find that as a standard that is used with fire alarms, that is the smallest conduit that they want used on this type of system. Let's look at our key note 1 up here. We have it, and also down here by this door. And it points to a square with a P in it. Okay, now that's your pull station, and that symbol's not listed in E0.1, but it says existing fire alarm manual pull station shall be relocated to new location shown, total of 2. Contractor shall provide and install all conduit and wire necessary for the relocation. Now we look at that note and we have a pull station, but how high should we mount that pull station? Okay, in order to find that on this set of blueprints, we need to turn forward a few sheets to sheet FA01. So let's do that right now. Here we are at sheet FA01, and it's the fire alarm device details. Now I wanted to point you here, this is the fire alarm notes right here, and I just want to point out note 23 down here. It says pull station shall be mounted no more than 48 inches above finished floor to the top of pull station. Now, if you remember earlier on the mechanical prints for the thermostat, we had a note on the height of the thermostats to be between a certain dimension, and that was because of the Americans with Disabilities Act. And of course, you would also want somebody, let's say, who's in a wheelchair to be able to pull the fire alarm pull station if necessary. That's why it's given there specifically that it shouldn't be above that height. The note on the thermostat you'll find on sheet M1.1 of the mechanical floor plan, and look at key note 4 on that page. Alright, so now let's go back to sheet E7.1 after you check out that note on sheet M1.1. So we're back on sheet E7.1. I'm going to point out now, here's a note 2 on a key note, and it's got a device. Look at this symbol. We have a square with kind of an X and a circle and a little triangle. And that symbol, remember, we saw on sheet E0.1, but it says existing fire alarm combination horn strobe device with candela rating as noted. So that's a horn strobe. Note 3, it's the same device as well, and it said they should be mounted at 80 inches above finished floor. Note 4, right here, now this is in the bathroom. It's got like a small circle with kind of an X, and it says new fire alarm strobe only device, so there's no horn in there. Now the reason for that, if you're in a very enclosed room like this and that horn goes off, it's going to echo in there, and it's really going to hurt your ears. So in there they said we're just going to have the strobe light going off. Down here, let's look in the storage room. There's a 7 and a 7. We spoke about this earlier, and it's got a C in here. Now it says new fire alarm control relay for fire smoke damper, total of 2. Contractor shall provide and install all conduit and wire necessary to tie in the new devices to the existing control initiating device loop. On the mechanical print, it had a different symbol for that. It was like an S for a smoke damper. So here we have slightly different symbols with different trades, but we spoke about these earlier. And remember, those devices were actually supplied by the manufacturer of that equipment, and all that the electrician would have to do would be to run the wire to those and hook those up. Okay, we have a key note here, 6 down to an S, and that's a new fire alarm smoke detector. So again, it's pretty simple here, and we're kind of going through this a little quickly here because we are going to have a specialized sheet for the fire alarm, and that page is given more importance than this page, and we'll point out the reason for that. Later on, we're going to go into some another sheet that has this information, but it's much more detailed, and it has precedence over this sheet, and we'll point out reasons for that. So I believe this covers what we need to learn off of this sheet, and I guess one thing we kind of got off of this too was there was some cross-referencing we did to find some information, and that was good for us. And again, this lesson's about learning to navigate through the blueprints and find what you need to know. So this concludes sheet E7.1 for us. The next sheet in our lesson is sheet FA01. If you look in the corner down here, it says cover sheet, and this is actually a cover sheet for the fire alarm plans. So now we're going to take first a wide look at the plans, and then we're going to zoom into some very specific areas of it. Right here in this column here, it's sequence of operation. It's kind of interesting to read. It doesn't really give us a lot of electrical information though. But if you're more interested in working with fire alarm plans, that's something you should just take a look at. Right here in the center, this tells us our project, where it is. Then it lists your architect, electrical contractor. Now again, there was an original fire alarm put in when you had this shell. So they have to have that, even if they just put the shell up, just in case there becomes a fire in that before it's completely built out. That's why this was in here. Approving agencies, it says Peoria Fire Marshal. This is in Peoria, Arizona. They're the ones who approve this plan. Type of system, it says it's a Class A wiring system. Okay. Codes and standards, NEC, National Electric Code 1999. Now you're thinking, well, wait a minute, this is 2005. How come we're using a code 6 years old? We'll get into that a little bit later. Gives a square footage of the building again. Now this says 3,762 square feet. Earlier we said 3,600 square feet. The slight discrepancy, that's really not our concern. We're building this out, so it's about the same size project there. Let's take a closer look now of some things in here, because it starts to get a little more interesting. Okay, so we're in the bottom right corner of this sheet. Okay, so it says now scope of work, conduit and boxes by electrical contractor. You can see that. Okay, wiring by TBD, to be determined. Same as the trim work. These are to be determined later. Sometimes a company that specializes in fire alarms will put in the wiring and the devices. Sometimes the electrical contractor does some of that work. Generally speaking, the electrical contractor will put in the boxes in the wall and the conduit risers out of the wall. And if it's a type of system that has to be all piped together between boxes and devices, the electrical contractor typically does that as well. And oftentimes they put a pull string in. Those are some things you have to look at, and of course if you're working with your contractor and the general contractor, they'll tell you how much of this work you're going to be doing. Now the important thing in this corner, this is an approval stamp. It's approved, we're checked. It says plans review. We're approved with corrections. Okay, we're approved here, and it says disapproved. So you want to be checked right here, at the very minimum right here. And it gives the date that we were checked on. It says fire. Now, you need this stamp in order to go ahead with building the building. Okay, when you go to get a certificate of occupancy that allows a tenant to move in, you have to meet the fire safety codes. Otherwise, you're going to be endangering the lives of people. So that stamp, this is very, very important to have. This says that the fire alarm system you're putting in is approved by the fire marshal. Now you can't just go in and put in anything you want and say, well, yeah, this worked over here, it should work here. You know, it's not like putting a couple convenience plugs on the wall. This is very, very important, and this approval stamp is very, very important to have. So I just wanted to point that out. Even though, well, this was put in is kind of a standard thing in one sense, but to get the stamp with these check marks, that is something that is stamped on, and again the fire marshal has to approve that. So, and of course anytime during the construction, if they don't think you're putting this system in properly, they can move you from approved down to disapproved. So keep this in mind. This is not a place where you want to be taking any shortcuts whatsoever. We're going to start looking at some of the other aspects of this page of the prints, and we're going to go to the fire alarm notes, and that was the second column of notes from the left. So let's go take a closer look at those right now. Okay, so here we are right here, the fire alarm notes. Let's go down to note 4. It says all system wiring below 7 feet above finished floor shall be in conduit or concealed. 7 feet is 7 times 12 inches, and that's 84 inches. Now we earlier spoke of some other devices mounted at 80 inches above finished floor. So we're right in that range of overlapping. They're saying at 84 inches, anything below that has to be in conduit. Now again, we mentioned not all fire alarm systems require the entire cabling to be in conduit. Some do. So, but they're saying anything below 7 feet above finished floor has to be in conduit or concealed. And concealed could be it's within a junction box, of course, which is a conduit body. And so where do we get our finished room ceiling heights? We can use the reflected ceiling plan. And there are also, there's a page on the architectural drawings, I believe it's 4.2 on this lesson. You can check me out to see if I got the correct number on that, but on the architectural sheets there's also a page that has that as well, the finished room schedule. Let's look at notes 8 and 9. Okay, FACP fire alarm control panel and NACP notification appliance circuit panel shall be mounted in an environmentally controlled area. 9. FACP to be mounted on 3/4 inch plywood or unistrut panel. Panel is not allowed on concrete or block walls. Okay, so this is giving you, when you install this, make sure you mount it on a 3/4 inch sheet of plywood. 10. FACP fire alarm control panel shall be mounted at 70 inches above finished floor to the top of the panel. So that's something you have to keep at the top of that panel, 70 inches above finished floor. Let's look at note 16 here. It says no smoke detector shall be closer than 36 inches to any air register or diffuser. And note 17, no heat detector shall be located closer than 18 inches to any air register or diffuser. And note 18, no heat detector shall be closer than 12 inches to any part of any light fixture. And let's look at note 19, no heat detector shall be located closer than 36 inches to any part of any heat generating device in mechanical rooms such as flues, boilers, water heaters, etc. Now we can find the locations of these things on the reflected ceiling plan, and also on sheet M1.1 we can find where all these registers, diffusers, and things like that. So when they lay out the locations of these devices, you have the ability to move those slightly so that you don't get them too close to any one of these. Okay, let's look at note 22 because we have something important here. Horn strobes shall be mounted 80 inches above finished floor to the bottom of horn strobe, or 6 inches from ceiling to top of horn strobe, whichever is lower. On the other notes we said things should be mounted to the center unless otherwise noted. Well, who makes the determination? Well, we mentioned earlier if something is on the same page as the print, we use the same symbol as that. But I want to just slide this over and point something out to you. See this right here? Remember this? Okay, this sheet, this stamp is on the sheet that is telling you that you should mount these 80 inches above finished floor to the bottom. So even if it says somewhere else to do it to the center, this sticker is on the one that says do it to the bottom. Now if you work out with the fire marshal and the general contractor and everybody else, and if they allow a change, they will put that change in writing and say, okay, this is a variance from the original approval, but we still say that the variance is going to protect the building and the people inside the building, and we approve the variance. But I just want to point that out to you. You have this stamp on a sheet telling you something different, so the thing that's different is been given the approval. Okay, so we're back to our fire alarm notes, and we covered note 23 earlier. Pull stations shall be mounted no more than 48 inches above finished floor to the top of the pull station. We're going to just slide over a little bit towards the fire alarm symbols. We'll take a look at there. Now again, we've kind of seen these before on page E0.1, but the symbols given here are actually slightly different, and they will apply to the diagram or the floor plan that we see on the next page. So we're going to be using these. They're still very similar. However, these are the ones that we're going to use. The one that I want to point out is here for the strobe. It has an L in it, it has a square, and it has this like little trapezoid to the right. Remember before that we had a symbol and it had like an X in it and some other things, and I don't want to try and describe that, but you can look back on E0.1 and see what the strobe looked like. And also the horn is different as well right here. But we will be seeing these types of symbols on the next page when we look at that. Okay, I also want to point out here, indoor fire alarm junction box to NEMA 1 12 by 12 4. So our fire alarm control panel, this is what it has to be. They're telling the size is 12 by 12 by 4 inches for that. And typically you're going to find that it's going to be red. So it's identified as fire alarm. Okay, let's slide over a little more. Okay, fire alarm cable schedule. If it gives an A, it's 16 gauge 2 conductor shielded. If it's a B, it's 14 gauge 2 conductor. So on your print, it'll have an either A or B on the cables. Calculation of voltage drop, that's kind of an engineering thing. I'm not going to get into that. This device address legend, I want to take a closer look at that because we will be dealing with that on the next page and we need to learn how that works right now. So let's take a closer look at that. We're going to find some symbols on our prints and some numbers that go with them, and also on our one-line diagrams for this electrical work. And so we need to learn how to identify them. Now here's the horn strobe, the symbol for that. The strobe, of course, is just an L there. Candela rating 15 CD, and that's like a decibel rating that tells how loud that device needs to be, and it will say that at each device, and you can adjust it on the device. So this will tell you how loud to make that one. NAC, notification appliance circuit name, S1. So on circuit S1, the address is 01. Okay, so circuit 1 could have, let's say, 10 devices on it. So this is device 1 on circuit 1. And on a very, very large building that has many, many more circuits than this one, that's how they're going to tell, because it's in the computer and they say, well, the fire alarm goes off. And they say, well, where is the fire? Well, they'll be able to monitor that and say, okay, it's on circuit 1 and it's device 01. And then they'll have a computer which will kick up in the building. It will tell you what part of the building it's in. And if they're reading that and they say, okay, now device 2 goes off, and now device 3, they can tell that the fire is moving in that direction. So this helps the rescue people in their efforts, and it helps just to monitor the building and helps to keep it safer. And we'll cover these numbers a little bit more, but again, we just want to point out that this would be circuit 1 and the address is 01 or device 1 on that circuit. We're going to move down more towards the center of the print at the bottom and look at some things there. Okay, we're looking now at the device details right here. It says not to scale. So I want to point that out, so you can't scale off in there. And it talks here, okay, a finished ceiling, 6-inch minimum from the ceiling to the top of the notification appliance. Okay, now we said NACP, notification appliance circuit panel. So this is like a horn strobe. Okay, now bottom of appliance to be not less than 80 inches or greater than 96 inches above finished floor. And it gives per National Fire Protection Agency, and it gives their code number. Here, appliance shall be placed 80 inches above the highest floor level or 6 inches below the ceiling, whichever is lower, per Americans with Disability Act. And it gives the section there. Okay, now here we have fire alarm control panel, 70 inches to the top. Finished floor. Remember we mentioned that earlier. The power supply. Okay, that's this, the NACPS. Same thing. They're saying 70 inches to the top. Now remember we had to mount this on 3/4 inch plywood. Now here's, it's given for a device 26 inches below the top in a sleeping area. Okay, this is not a sleeping area, so this is kind of a general stamp that could go on all the prints. We talked about these things earlier in specifics, but a picture's worth 1,000 words, I guess. Okay, so it's time we're going to move over to here to some other details on the page. These last two little diagrams here, it says horn strobe and strobe. And these are some simple wiring diagrams. And it tells here, you mount this in a single gang box or 4-square box with one gang ring mounted at 80 inches above finished floor, 6 inches below ceiling, whichever is lower. So we know we're going to put this in a box, same detail here. When it comes, it says for this particular application, it says remove jumpers A and B to select isolated horn and strobe power input. So that's what you're going to do. You're going to remove the jumpers from A and B off of this device. The second note says jumper C selects between temporal or non-temporal tone. Jumper isn't temporal. So in other words, when the tone it goes bat, bat, whereas otherwise it would go bat. So anyway, it's in temporal. So, okay, jumper D selects between mechanical or high frequency tone. Jumper is in mechanical. The owner of the building will select that unless it's given to you to do by the fire marshal. Okay, jumper E selects between high or low dB. Jumper is in high dB or decibels. Now we're given these things on how we have to do this. Now this says the red wires, you have to have them, once you look at it, there's going to be these 6 terminals you can land them. You're going to have 2 sets of cable, each with a red and the black wire going into this. And you can see this, both black wires are going to go to the 3rd one from the top, and the red wires are going to go to the 1st and the 2nd one. So this gives you the detail on how to wire it for this system. Now on the strobe, if we look at it, it's pretty much the same on the wiring. And that's nice because we won't end up getting those two confused if they're different. If they were slightly different, there could be a problem with that. Now again, fire alarm things are highly specialized. They change quite frequently because as soon as they find a way to make something safer, they want to implement it. And so you really have to keep up on it, and in fact some electrical contractors really specialize in that. But oftentimes you will be installing these devices and putting them in, so you need to look at this and check this out. And of course oftentimes when the device comes in a box you have an instruction sheet, so read those instruction sheets. You can learn quite a bit from them. Okay, so this covers sheet FA01 for us, so it's time to move over to the next page.
Thank you for watching this video. Please click on the like and subscribe buttons so that I can continue to make more videos like this. If you find this video helpful, please consider donating using the PayPal link below. Thank you.